So let's solve this question on Thevenin's theorem. We're asked that in the network above, find the current through the 10 ohms resistor using Thevenin's theorem. Now, of course, we know that in Thevenin's theorem, we try to connect our load resistor in series with a resistor and with a voltage. That means we're trying to resolve the whole of this circuit to something like this, so we can find the current or voltage through a load. But in this case, we are asked to find the current through the 10 ohms resistor. And where's the 10 ohms resistor? This is the 10 ohms resistor. So we're asked to find the current through this 10 ohms resistor. All right, so we're trying to reduce the whole of this into something like this, all right, into this diagram. Now, how do we do that? Now, we have to find, of course, we know we have to find the Thevenin's voltage, and we also have to find the Thevenin's resistance. Now, let's go ahead to find the Thevenin's resistance first. Solution: to find RTH, which is the Thevenin's resistance, all right? Now, let's go ahead to find the Thevenin's resistance. Now, how do we find the Thevenin's resistance? We find the Thevenin's resistance by shorting all the voltages, all right? All the voltage source or even current source. So now look at, this is a voltage source, this is a voltage source, this is a voltage source. This 10 volts, this 12 volts, this 20 volts. So this is the same circuit. So we're going to short all these voltage source. So this is the 10 where we have the 10 volts. So we're going to short this. All right, we're going to short circuit it, meaning right now there's no voltage source here right now. So we're going to short circuit every single voltage source. So there's a voltage source here. We're going to short these two. All right, we're going to short these two. All right, and there's a voltage source here too. We're going to do the same for this. All right, we short this, and then we're going to leave this part open because this is where we have the 10 ohms resistor. So let's just call this point AB. So this is our RTH. That's where we have our Thevenin's resistance, because we're looking for the current through the 10 ohms resistor. So we're going to open it. All right, it's going to be open. So don't forget, this is what, 2 ohms. All right, this is 1 ohms. All right, this is what, 5 ohms. All right, 5 ohms resistor. So the first step for us to find the Thevenin's resistance, all right, we have to what, short all the voltage source. All right, we have to short it. All right, that means there will be no current or voltage flowing through those parts. So that's the first thing. Now, looking at this diagram, now that we've short all the voltage sources, looking at this diagram, you'll find out that this 2 ohms resistor is in parallel with this 5 ohm resistor, and it's also in parallel with this 1 ohm resistor. Don't forget we're looking for RTH. So RTH now is going to be that the 2 ohms resistor is in parallel with the 5 ohms resistor. It's also in parallel with the 1 ohms resistor. So how do we do that? It becomes what? Let's find the total resistance, which is equivalent to finding the what? The Thevenin's resistance. So it's going to be 1 over RTH over 1 over 2 plus 1 over 5 plus 1 over 1. All right. So now this is going to be 1 over RTH, all right, is equal to what? 1 over 2 plus 1 over 5 plus 1. Now, what are we going to do? We're going to find the LCM. LCM of 2 and 5 is what? LCM of 2 and 5 is 10. So it's going to be 10. 10 divided by 2, that gives us what? 5. 5 times 1, 5. Plus 10 divided by 5, that gives us 2. 2 times 1, 2. Plus 10 divided by 1 gives us 10. 10 times 1, that gives us 10. Alright? So this is going to be what? 1 over RTH is equal to 5 plus 2 plus 10. That gives us 17 over 10. Alright? 17 over 10. Now, it means that inversing both sides, that's finding the inverse of both sides, RTH now itself is going to be 10 over 17. Alright? Which is the same thing as 0.588 ohms. Alright? So now we found our Thevenin's resistance, all right, to be what? 0.588 ohms or 10 over 17 ohms. All right. Now, what's the next step? we have to find our Thevenin's. This is first step. Second step, we have to find our Thevenin's voltage. All right, we have to find what our Thevenin's voltage. So let's go ahead and find our Thevenin's voltage, and this is the diagram we're going to use. All right, let's go ahead and find our Thevenin's voltage. Now this is 10 volts, this is 2 ohms, this is 5 ohms, this is 12 volts. We're not shorting any circuit. All right, everything is going to be intact, but we're not going to put in place this resistor, all right, which we're looking for the current. We're going to put VTH here, and then this is going to be 1 ohms, and then this is what, 20 volts. All right, 20 volts. All right, this is what we have here. All right, sorry, this is supposed to be negative and then positive. And make a correction to this. That's for this. All right, don't forget that all this we are doing is to find what, VTH. So this is the correct placement of our voltage source here. That's for the 12 volts. So this is what we're going to have. So we want to find VTH, all right? And at this point, this is, let's call this V1, all right? Let's call this node. This is a node, all right? Let's call that V1. Now, we're going to apply nodal analysis. Applying nodal analysis. Now, you agree with me that what, the voltage flowing through here will be the same voltage flowing through here, right? Because of course, you know, in parallel, when two things are connected in parallel, they have the same voltage. So this line is in parallel with this line. So the same voltage flowing through here will be the same voltage flowing through here. So if you can find V1, we found VTH. All right. So which we're going to use nodal analysis in this case to find what, V1, which is the same thing as finding VTH. All right. So now applying nodal analysis. Now this voltage is flowing from here down here. So this is, let's call this, let's call this, let me use a red pen. Let's call this I1. All right. Now, then this voltage is going to flow from here, enter here. So let's call this what, I2. And then this voltage source is coming from here. All right. It's coming from here. So it's going to be flowing in this direction. Let's call this I3. All right. Let's call this I3. Now, we're using nodal analysis, and we use Kirchhoff's current law when it comes to nodal analysis. So this current is entering and this current is leaving. So it means that current entering, don't forget Kirchhoff's current law, current entering, right, I1 and I3 are entering is equal to what, current what, leaving, I2. All right. So let's solve this. Let's go ahead and solve this. Now for I1, how are we going to do for I1? Now, I1, there's a higher voltage flowing here than here. All right. There's a higher voltage potential here than this node here. So it's going to be, for the voltage, don't forget that current is what, V over R, voltage over resistance. All right. So it's going to be what? It's going to become what? That's going to be 10 minus V1, all right? The potential difference and the potential difference is difference. That's going to be 10 minus V1. That's for I1 now, over, what's the resistance? The resistance is what? 2 plus, now for this, which is I3, all right? Now we know that there's a higher potential flowing from here than here. So it's going to be what? 20 minus V1, all right? 20 minus V1 over, what's the resistance? Resistance is what? 1, all right? Is equal to, now what's I2? I2 is what? The voltage flowing through here. And the voltage flowing through here is what? Is going to be V1 plus 12 volts. If there was no 12 volts here, let's assume it is going to be just V1 over 5. But in this case, it's going to be V1 plus 12. All right. The voltage on this node here plus this voltage divided by what? The resistance 5. All right. So now we're going to multiply through by the LCM of denominators. So the LCM of the denominators, because this is going to lead us to an equation, all right? So the LCM of the denominators is 10. So we're going to multiply through by 10. So multiply through by 10. Multiply through by 10. So when you multiply through by 10, it becomes what? 10 times 10 minus V1 over 2 plus 10 times 20 minus V1, alright, is equal to 10 times V1 plus 12 over 5. Then, now let's continue. So 2 goes here 1, 2 goes here what? 5. Alright. Now, this 5 goes here 1, 5 goes here what? 2. Alright. So we're going to be left with 5 multiplying what? 10 minus V1 plus 10 into bracket 20 minus V1 is equal to 2 into bracket V1 plus 12. Alright, that is what we are going to have here. Alright, I hope you understand that. So now let's continue. So let's continue from here. Now we're going to have what? Now we're going to have 5 times 10, that's going to be 50. 5 times 5 times V1, that's going to be what? Minus 5V1 plus this times this is going to give us what? 200. All right, 200. All right, and then this times is going to give us minus 10 V1. All right, is equal to what? 2V1. All right, 2V1 plus what? 24. All right, so now let's continue. So we want to find what? V1. All right, so this is 50 plus 200, that gives us what? 250. Now minus 5v1 minus 10v1 gives us minus 15v1 is equal to 2v1 plus 24. All right, so now taking this here and taking this here, we're going to have 15v1, all right, plus 2v1 is equal to what? Is equal to what? 250 minus what? 24. So that's going to give us what? 17v1 is equal to what? 226. So v1 is going to be equal to 226 divided by 17, which is going to give us what? 13.29 what? Volts. All right, 13.29 volts. All right, so now, and we know that V1 is the same thing as what? VTH. And V1 is the same thing as VTH, which is the Thevenin's voltage. That's 13.29 what? Volts. All right. So now, coming back now, we found what? RTH. All right. And we've also found, we've done all this to find what? VTH. All right. Now, we now have what we need. All right. Now, coming back here, all right, we have been able to find the Thevenin's resistance and the Thevenin's voltage. All right, so what do? So now we know that VTH is equal to what? 13.29 volts, and we know that RTH is equal to what? RTH, what did we get in RTH? We got 0.588 ohms. All right, now we can now find the what? The current through this load resistor, which is what? 10 ohms. All right, our load, which is our resistor, is 10 ohms. So what formula do we use? Now the current is going to be, the formula is what? VTH over what? RTH plus RL. So this is going to be equal to what? 13.29, all right, over what? 0.588 plus 10. So this is going to give us our final answer as 1.255 ampere. All right. So the current flowing through this 10 ohms resistor, all right, is what? 1.255 ampere. And this is going to be what? Our final answer. All right. So that is how to find the Thevenin's, how to use Thevenin's theorem to find the current through the 10 ohms resistor in this what? Circuit, or in this network. So we started from here, all right. We found the Thevenin's resistance, all right. Then we went ahead to find the Thevenin's voltage, all right, which we started from here, continued from here, we got this, and then now we now have the Thevenin's equivalent circuit, which you now use to find the current flowing through the 10 ohms resistor. All right. So that's that for this video. Make sure you like this video, share this video, and I'll be uploading more videos on this. Make sure you watch more videos on this. And if you're having any challenges, make sure you put it in the comment section, and I will do well to give you a reply on answer.